NASA's Spitzer Space Telescope has detected 7 rocky planets orbiting a tiny nearby star called TRAPPIST-1. 3 of these planets are firmly in the habitable zone, which means they have the right temperature and pressure to allow liquid water on their surfaces. And liquid water is essential for life as we know it. But how did NASA find these planets? And what makes them so special? In this video, we will answer these questions and more as we explore the incredible world of TRAPPIST-1 and its 7 Earth-like siblings. Please give this video a thumbs up and subscribe to this channel for more videos before we proceed. Click the bell icon to receive notifications of new videos. Have you already done this? Let us start. TRAPPIST-1 is a star that is very different from our Sun. It is an ultra-cool dwarf star, which means it is much smaller, dimmer, and cooler than our Sun. It's only about 8% of the Sun's mass and 11% of its radius. It's also much younger than our Sun, about 500 million years old, compared to 4.6 billion years of our Sun. It's located about 41 light years away from us, which is relatively close in cosmic terms. It's part of the constellation Aquarius, but it's too faint to be seen with the naked eye. It was first discovered in 2015 by a team of astronomers using a telescope called TRAPPIST, Transiting Planets and Planetismal's Small Telescope, in Chile. The telescope was designed to look for planets around low-mass stars like TRAPPIST-1. In 2016, the same team announced that they had found 3 planets around TRAPPIST-1 using the transit method. This is the technique that measures the tiny dips in the star's brightness. The size and frequency of the dips reveal the size and orbital period of the planet. In 2017, NASA's Spitzer Space Telescope joined the hunt and confirmed the existence of 2 of the planets and discovered 5 more. Spitzer also measured the precise sizes and masses of all 7 planets using its infrared vision. This allowed scientists to calculate their densities and compositions. All 7 planets are similar in size and mass to Earth. They are also likely to be rocky, rather than gaseous like Jupiter or Neptune. And 3 of them, TRAPPIST-1e, F, and G, are in the habitable zone of their star, meaning they receive enough sunlight to keep water liquid on their surfaces. Why might these planets be habitable? The habitable zone of a star is the range of distances where a planet can receive enough energy to keep water liquid on its surface. Liquid water is essential for life as we know it, so finding planets in the habitable zone is a key step in the search for extraterrestrial life. The TRAPPIST-1 planets are all similar in size and mass to Earth, which suggests they are rocky and have solid surfaces. They are also likely to have similar composition since they formed from the same disk of material around their star. This means they could have similar amounts of elements that are important for life, such as carbon, oxygen, nitrogen, and phosphorus. However, the TRAPPIST-1 planets are very different from Earth in other ways. They are much closer to their star than Earth is to the Sun, which means they receive more intense radiation and tidal forces. They are also very close to each other, which means they interact gravitationally and influence each other's orbits and climates. These differences could have significant effects on the atmospheres and habitability of the TRAPPIST-1 planets. To determine whether any of the TRAPPIST-1 planets have atmospheres and what they are made of, astronomers need to observe them when they transit their star. By measuring how much starlight is blocked by the planet and its atmosphere at different wavelengths, astronomers can infer the chemical composition and thickness of the atmosphere. So far, only a few observations have been made with telescopes such as Hubble and Spitzer. These observations have ruled out some scenarios, such as hydrogen-dominated atmospheres for some of the planets, but they have not been able to detect any definitive signs of atmospheres or biosignatures. To get more detailed information about the TRAPPIST-1 planet's atmospheres and habitability, astronomers need more powerful telescopes that can observe them in infrared light. Infrared light can penetrate deeper into the atmosphere and reveal more clues about their temperature, pressure, and chemistry. Can we reach these planets? The TRAPPIST-1 system is one of the closest planetary systems to Earth, but it is still very far away. It would take about 41 years for light to travel from TRAPPIST-1 to Earth, which means we see the system as it was 41 years ago. To reach it with a spacecraft would take much longer. The fastest spacecraft ever launched by humans was NASA's New Horizons probe, which flew past Pluto in 2015. It reached a speed of about 58,000 kilometers per hour, 36,000 miles per hour at its peak. At that speed, it would take about 817 1,000 years to reach TRAPPIST-1. To reach TRAPPIST-1 in a reasonable time frame would require much faster spacecraft and propulsion systems that do not exist yet. Some possible technologies that could enable interstellar travel include nuclear fusion rockets, antimatter engines, solar sails, laser beams, or wormholes. However, these technologies are either theoretical or very challenging to develop and test. Therefore, for now, we can only explore TRAPPIST-1 with our telescopes and imaginations. But who knows what the future may bring? Maybe one day we will be able to visit these distant worlds and see for ourselves if they are truly habitable or even inhabited. What will NASA do next to find out if these are really habitable? NASA is not giving up on finding out more about TRAPPIST-1 and its planets. The agency has several missions planned or proposed that could help answer some of the burning questions about this fascinating system. One of these missions is the James Webb Space Telescope, JWST, which is scheduled to launch in late 2021. JWST is a giant infrared telescope that will be able to observe TRAPPIST-1 and its planets in infrared light, which can penetrate deeper into the atmospheres and reveal more clues about their temperature, pressure, and chemistry. JWST will use a technique called transmission spectroscopy to measure how much starlight is absorbed by the planet's atmospheres at different wavelengths. This will allow astronomers to infer the chemical composition and thickness of the atmosphere. JWST will also use a technique called emission spectroscopy to measure how much infrared radiation is emitted by the planet's atmospheres and surfaces at different wavelengths. This will allow astronomers to infer the temperature and heat distribution of the planets. JWST will observe all 7 planets, but it will focus on the 3 in the habitable zone, TRAPPIST-1e, F, and G. These are the most promising candidates for habitability and life. JWST will try to detect molecules that are important for life, such as water, carbon dioxide, methane, and oxygen. It will also look for signs of clouds, hazes, or seasons that could affect the climate and habitability of the planets. JWST will not be able to definitively answer whether any of the TRAPPIST-1 planets are habitable or inhabited, but it will provide valuable information that will help narrow down the possibilities and guide future observations. Does life exist on these planets? The ultimate question that everyone wants to know is, does life exist on any of the TRAPPIST-1 planets? The answer is, we don't know yet, but we are getting closer to finding out. Life is a complex phenomenon that depends on many factors, such as the availability of energy, water, nutrients, and a stable environment. Life also produces distinctive chemical signatures that can be detected by remote sensing. These are called biosignatures. Biosignatures are molecules or patterns that indicate the presence of biological activity on a planet. For example, oxygen is a biosignature because it is produced by photosynthesis on Earth. However, oxygen can also be produced by non-biological processes, such as photodisassociation or oxidation. Therefore, biosignatures need to be interpreted carefully in context with other evidence. To detect biosignatures on the TRAPPIST-1 planets, astronomers need to observe them with more powerful telescopes than JWST. These include ground-based telescopes such as the Extremely Large Telescope, ELT, in Chile, or the 30-meter telescope, TMT, in Hawaii, which are expected to be operational in the 2020s. These telescopes will be able to observe TRAPPIST-1 and its planets in visible light, which can reveal more details about their atmospheres and surfaces. Another possibility is to send a dedicated space mission to TRAPPIST-1 that could perform direct imaging of the planets. This would involve blocking out the starlight with a device called the coronagraph, or a star shade, and taking pictures of the planets directly. This would allow astronomers to measure their colors, brightnesses, phases, and features. TRAPPIST-1 is a remarkable system that has captivated our imagination and curiosity. It has shown us that there are other worlds out there that could be similar to our own. It has also challenged us to find out more about them and their potential for life. NASA and other space agencies are working hard to explore TRAPPIST-1 and its planets with their current and future missions. They are also developing new technologies and techniques that could enable us to visit these distant worlds one day. Today's video has come to an end. Remember to give this video a thumbs up and subscribe to the channel for more content. Remember to click the bell symbol to receive notifications when new videos are posted. I will leave you with this and hope to see you in the next video.